For this problem, we're going to find the complex zeros of a function. We're going to find the complex zeros of the function f of x equals 2x squared plus 4x plus 5. To find the zeros, we set f of x equal to 0, which means we need to solve the equation 2x squared plus 4x plus 5 is equal to 0. This is a quadratic equation. If we identify the coefficients, a is equal to 2, b is equal to 4, and c is equal to 5. We can go ahead and use the quadratic formula. If we first find the discriminant, that is b squared minus 4ac, we'll have 4 squared minus 4 times 2 times 5, which is equal to negative 24. Since the discriminant is negative, we know that this quadratic equation will have two non-real solutions. We're going to use the quadratic formula. We'll get x is equal to negative 4 plus or minus the square root of b squared minus 4ac, which we found to be negative 24. And all that's over 2 times 2. This will give us negative 4 plus or minus 2i, is the square root of 6, divided by 4. And we get the square root of negative 1 is I, the imaginary unit. We can cancel a common factor of 2 in the numerator and denominator. This will give us x is equal to negative 2 plus or minus I root 6 divided by 2. Therefore, our complex zeros will be negative 2 minus I root 6 over 2, and negative 2 plus I root 6 over 2. We could write these in standard form for complex numbers as negative 1 minus the square root of 6 over 2i, or negative 1 plus the square root of 6 over 2 times I. Here we have the standard form, or we could write it just from our result from the quadratic formula. So here we have our complex zeros.